Hello, it's Jessica here, and I'm honored to host the last session of Kaggle CareerCon 2019. For this session, we lift the curtain to reveal what hiring managers are actually looking for. These days, it's such a common feeling to scan job descriptions and feel like hiring managers are looking for impossibly well-rounded and experienced data scientists. Do hiring managers actually expect you to have every skill listed? How do you know which skills are actually important? Ruben Kogel, head of data analytics at Lime and seasoned data science hiring manager, is here to give you the inside scoop on deciphering what truly matters the most when applying for jobs. Before Lime, Ruben built the data science function at VSCO, a creative platform for photographers, and also led the content analytics team at Udacity. Take it away, Ruben.
Thanks, Jessica. It's a pleasure to be talking here at Kaggle's CareerCon. And I guess like the topic I wanted to address has to do with maybe some of the misconceptions that candidates have about what it takes to get a data job, what are hiring managers looking for. And so I'm hoping to use like the next hour to address this issue. And in particular, I want to deconstruct how we get there. Why is it that there's a bit of a discrepancy, and why is it that hiring managers are looking for certain traits or skills? So let me start by briefly introducing myself. So as you heard earlier, I'm currently the head of data analytics at Lime. Lime, you may have heard of, is a e-scooter and e-bike company. It's been growing really fast. Basically, we are above 600 people right now, present in more than 25 countries, and the company has been seeing a tremendous growth. So it's an exciting job, but also a lot of growing pains that we have to manage. Before that, I was a director of data science at Visco. I built the data practice there. And it was also like an incredibly interesting experience. And before that, I led content analytics at Udemy. So one of the first questions I want to address is what is data science? When you talk to people, when you read blogs, if you go to certain also boot camps or programs, this like word or name of data science is used in many different contexts. And often I find that there is some confusion about what really is data science. And I don't think that we as an industry has done a very good job at defining it. So let me list out some of the confusion that we have right now. So usually when you talk to execs who are, the ultimate hiring managers, the one building the company, usually what they want is insights. They want to know how the business is doing, how can we do better of it. They want to get like those data insights. They may call it data science, they may call it something else, but ultimately that's what they want. Then when you look at deeper in organizations, and you kind of look at like what are the needs from the organization in terms of function, you realize that there are different needs for different function. There's a business or product or marketing analytics need. So that means understanding how the business is functioning and how, what's driving it, understanding, users' interaction with the product and some of the tests, understanding also how users or customers hear about the product, come to the platform through marketing analytics. But that also involved a need for like experimentation. How do we design experiments correctly? How we analyze them correctly so that we can get the learning and move our ultimate business goals. There's also a need for sometimes predictive modeling. For example, a company like Lime might be interested in knowing what will be the demand today, the day after, in a week, so that we can plan supply accordingly. So we can also work with our juicers, our mechanics accordingly, so that predictive modeling is quite important. We also apply that dimension to fraud detection. When users rent a scooter, there might be some abuse, and our ability to detect the abuse is very important for our financial health and our relationship with different payment systems. Finally, data can also means like we build data products. So that could be dynamic pricing. It could be, again, fraud detection is sort of a product. So there are different ways in which data plays into an organization. And sometimes data science refer to all those needs together. Now, when you talk to students or applicants, often they think that data science is about using the most advanced statistical techniques. So they've spent, you know, from a couple of weeks to maybe a couple of years learning the trade in school, and at the end, they're just excited to use SVM, random forest, neural networks, and they think that it's mostly about using those techniques. But when you talk to practitioners in the field, and especially like in larger companies, they will tell you that it is mostly about counting, which is counterintuitive because you think that counting is the most basic thing and it's anyone can count. But it turns out that you can solve 80 to 90% of problems just by counting things properly. If you, let's say like you design an experiment that you want to increase conversion of new users, just analyzing the experiments at the very basic does not require any sophisticated statistics. It just require counting how many people were in the experiments, how many people saw the first variant, the second variant, and what was the conversion rate, what was the total revenue we got in different variants of the experiments. All of that have to do with counting. And while it might seem like a very basic and easy thing to do, it turns out that in practice, this is the hardest part because you're never facing with an accurate count. You're never facing with like clean, perfectly organized data. And you have to spend your time understanding like how the data was generated and which person corresponds to which variant of the test. Do things mean exactly what we think they mean, et cetera, et cetera. So in practice, practitioners like me will tell you that just counting things correctly is probably the hardest thing and 80% of the job in practice. So I've already alluded to like potentially different functions of the company, but at a company like Lime, we actually make a distinction between data analytics and data science. What's important to know is that this distinction is not necessarily made at other companies. If you take, for example, Facebook as an example, or LinkedIn, they tend to call everyone data scientist, and that's totally fine. And in some cases, companies or organizations have started calling the more research-oriented people research scientists, and the more analytics-minded people data scientists. And again, the goal here is not to decide on the perfect nomenclature or decide what should people be called. It's more like to give you a flavor of that. Sometimes the same title can mean different things. But it's important to understand really what different roles people are playing. So let me go through how things work here at Lime, and you can probably translate that with other terms for other companies. So the team that I'm heading at Lime is called Data Analytics. And basically, we think of this team as serving internal customers. So customers might be product managers, might be the operation team, might be the strategy team. It includes also the finance team, business development. Those are people who are making decisions every day, and they need data insights in order to help them make decisions. So they need insights to understand how is my particular area of the business doing, and how can I improve on its performance. So an example of that might be someone is in charge at Lime of optimizing, maybe of understanding whether we have the right scooters distributed in a city correctly. So the first question is, which data should I even look at? What metrics should I look at? What can I learn from looking at historical data, doing some look back analysis, and what might be the drivers of oversupply or undersupply in certain parts of the city? So all of that falls into data analytics, and all of that are questions that a decision maker might be asking of data in order to improve the business. And then it usually doesn't stop here. It also continues into, once we have a better understanding of the problem and what's driving it, usually we also make recommendation on how to improve it. Those recommendations might turn into experiments. Then we analyze experiments, and we can get the learning and start iterating from there. So that whole process is really what data analytics is about. And I think it's important to recognize that in most cases, it does not necessarily require very sophisticated statistical techniques or analysis. It's really about having like a really strong sense of what the product is, how it works, how people interact with the product, what are the business outcomes we're trying to move, what are the important metrics we want to optimize against, as well as using sound scientific methods, both to analyze the data, draw the correct conclusion, and suggest the right experiments to test new hypotheses. Now, there's also data science, which is the flip side of data analytics. And data science tend to serve a mix of internal and external customers. Usually, there is a lot more of predictive modeling. So, for example, we want to be able, as I mentioned earlier, we want to be able to detect fraud in our payment. So the way it works is we take historical data that has been labeled, that we know which one is actually fraud or not. We learned features about that data, and then we produce a model that hopefully can correctly classify whether a particular payment is fraudulent or not. And then once we have that model, we need to implement it in some sort of like a production environment. It is a living model that will automatically detect and potentially stop fraudulent payments. So that's one example. Another example might be also dynamic pricing, adjusting the price of a scooter reservation based on supply, demand. Again, initially it looks at historical data, but quickly it turns into a model that is embedded into the product because it interacts directly with the user experience. So the common theme in all those work streams is that it requires very strong scientific methods to being able to correctly draw the correct conclusion from the data, as well as build models that are both simple but robust and basically create the right outcomes, as well as some data engineering skills, because in a lot of cases, the model become a productionized model. And in order to do that, it's important that it plays well with the data pipelines and the data infrastructure. So how do you almost instantaneously receive the data, apply a certain model, export the output, and stop a fraudulent payment? This becomes like an engineering problem. And that's why data scientists needs to be very attuned to some of the infrastructure and engineering integration required for their models to work. It doesn't have to work. It doesn't work just on a sheet of paper or in a sandbox environment, but it has to work in practice, in production, and in some cases, like in almost a live real-time environment. Now, let me dig a little bit deeper about data analytics, because again, this is the one area that I'm more specialized about. I will touch also a little bit about data science, but I want to kind of get a deeper look into what data analytics is about, because once you understand that, you will understand also what hiring managers are looking for. It's all connected, and it all starts with what data analytics try to do and how it does it. So at its core, data analytics is about providing data insights to the business that inform how the business is doing and how to improve it. We already talked about it. And in practice, that involves doing some deep dives to potentially understand what are the causes of some of the depreciation we might have on scooters. It might be, do we understand really like what's driving the lifetime of some of our scooters by generation, by market? So those are deep dives, usually start with a fairly complex and might be in some cases ambiguous question. And from there, the analyst would start formulating a more precise question, doing some analysis, in some cases doing some modeling, and come back with a deep understanding of what's going on, as well as ways to improve that particular issue. Another one might be KPI instrumentation. KPI stands for key performance indicator. And that means that a lot of teams, they need to have some ways of measuring their performance, as well as their trend over time. If you're managing a warehouse, you want to understand whether you're managing it correctly. So you need like a metric to do that. You also need to be able to track things over time. And so designing those metrics as well as designing systems that allow people to understand the performance of their function and understand how it moves over time is also like a core function for data analytics. A third one we discussed earlier is about experiment design and analysis. Again, the idea here is that if we try things in the field or if we try things on our product, but the experiment has not been correctly designed or there's no experimental design, chances are that we won't be able to draw a conclusion from it. And chances are that we won't be able to tell whether the change we introduced was beneficial or not. And that's both a waste of time as well as a waste of learning. And one of the goals of analytics is to help people learn from changes, learn from experiments, and apply that learning to continuously improve the product. Then there are what we typically call ad hoc support. It might be a question from the PR team. It might be a question from the business development team. Sometimes it's a PM, a product manager that needs like a quick list of users that are doing certain actions, maybe a quick list of vehicles that are in a certain location under certain conditions. So we call that ad hoc support. And the idea is that most data analytics teams start by doing a lot of ad hoc support, but then as they grow in sophistication, they do less and less of them because they replace them with both deep dives on the one hand or self-serving tools on the other hand. And self-serving tools, which is the last part here, is really about designing tables, reference tables, dashboards, or general tools that let people extract the information they need on their own without having to submit a ticket, because frankly, no one likes to do like 20 simple data pulls per day. It's not very fulfilling. It doesn't really move the business on its own. And so better do either like a deeper analysis or better build tools that let people across the company extract the data that they need for their own projects. One thing that's very important is that in general, because the data analytics team produces insights and really is there to help business stakeholders make decisions, its value is only insofar as it's able to provide relevant, reliable, and timely insights. What I mean by that is that the data analytics team does not build any product, does not manage any operations in the field. And so really the way its performance can be measured is whether it's influenced decisions effectively at the company. And in order to influence decision, you have to have credibility at the company level. And the only way you get credibility is by giving relevant insights, so they are relevant to the problem at hand, reliable, because if you make mistakes or provide wrong insights and keep correcting yourself, you will lose credibility. And if you lose credibility, then you basically are not really useful anymore. And timely, because people need those insights to make decision. And so being able to provide them in a timely fashion is important to improve the decision process. And like a way to really summarize this is by saying that the goal of the data analytics team is to accelerate the feedback loop and drive better decisions faster. The feedback loop is we launch a new feature or a new product, we make a change, and we want to know whether that improves our business outcome. And so we do that by designing the right metrics, designing the right experiments, doing the proper analysis. And also we want to be able to drive better decisions by giving the organization a deep understanding of what's really happening, what could be done to improve business outcomes. And when we do that, we basically help the organization get to an optimum much faster and much more efficiently than if they were trying random features or random changes by themselves. So I think it's important here to a point I want to make is that organizations actually don't really need data analytics to make decisions. They don't need data analytics to build a business and to improve on it. But what data analytics provide is a way to make the more correct decision and faster. Because without data analytics, without properly understanding what's going on and properly learning from experiments, we might be making the wrong decision. It doesn't mean that we stay on that wrong decision forever, but instead of getting to the right decision immediately, we might random walk through a couple of suboptimal decisions, and we might be wasting time and not getting to where we need faster. So it's important. I wanted to provide this framework because it's really important to understand that this is the value that data analysts provide. Because once you understand that, you'll understand also what makes a successful data analyst, and in turn, that drives what hiring managers are looking for. So taking like those examples and basically listing them out. So the typical project that the data analytics team would be doing, one is like this series of deep dive that we talked about to gain a deep understanding of complex issues and provide recommendation. Spoke about like what's driving the lifetime of scooters at Lime. It might be also what's driving new user retention. And sometimes those problems are not simple, and you need the data analytics team to really breaking down into simpler terms and provide like a shared understanding, a shared set of vocabulary across the company. The second one, as we discussed, is design instrumentation to track progress against key business objectives. Again, it's very important in order for the company to be coordinated and to march together towards the right business outcomes. It's very important that the manager of a warehouse knows what to look for. So that person will need help. They will need help designing the right metrics. They will need help, which means in turn, do we have that data available? If not, can we work with engineering to make it available? Can we then port that data into some warehouse? Can we then port that data into a dashboard? So this whole like tracking of the information, designing what information we need, tracking that information, putting it together, and designing the system that let the warehouse manager or other business decision makers track progress is extremely important. Then we talked about building reference tables and dashboard to automate data insights. So that's the part around self-serving tools, which involves like understanding again like how data flows into like a database. What are the systems to build data warehouse? Concepts around pipelines, ETL. ETL means extract, transform, and load. All of that are critical to being able to design those systems. There's experimental design and analysis to accelerate the learning, as we discussed. And finally, like ad hoc support, which, as I said earlier, like the goal is really that this should be minimized in terms of a function for the data analyst. So once you understand like these are the main function, the main project the data analyst does, you basically realize that in order to be successful, you need like a series of skills and abilities and knowledge. So going back to that list, in order to be able to do correct deep dive, you need a lot of it has to do with like finding the data. So data collection, working with engineering, both like the data producers as well as data engineering is critical in order to gather the right information. Once you have it, it's very important to understand how to clean it. So data cleaning is an important skill here. Then there's cross-functional work, because you will have to work with engineering to understand where the data is coming from, what are any caveats on that data. You also need to work with your business counterparts, whether they are product managers or operations manager, to understand really what they're looking for. So that's very important. Once you have the data in one place, you need to apply rigorous scientific methods to analyze that data correctly. So, if we do like causal inference, that's like important to do it correctly. Might include like some basic modeling, as well as like some like business sense of like what are we trying to do exactly. And finally, once that is completed, like you will often need to communicate your results to your business stakeholder. And no matter how good or sophisticated analysis is, if you cannot communicate the findings to a director of operations or a VP of product, then it's useless. So communication is extremely important here in order to equip the organization with that understanding of the problem. Now, if we look at instrumentation again, being able to like design the right metrics means that you will need a good product sense, a good business sense. You also need to understand how pipelines work, how data warehouses work, as well as attention to details. Because if you build a logic to create a new table or logic to create a new metric, are you protecting against like edge cases? Did you take into account all of that, maybe like redundancy? There might be duplicates. So being able to like attend to all these details is extremely important, as well as like working cross-functionally, because you would be working with engineering on the one hand again, and business stakeholders on the other hand. Same thing with building reference tables. Like the same set of skills apply. Experimental design analysis, as we discussed, requires knowledge of scientific methods for designing experiments, knowledge of correct statistical tools and analysis to analyze the result of a test. Are you using a chi-square test? Are you using a t-test? And you will have to justify all of that. Do we use like a p-value? What is the downside of just relying on p-value, etc. And finally, for ad hoc is really attention to details and communication. So to summarize those things, we can say that in order to succeed, data analysts will need a combination of different things. They will need technical skills, coding skills. That includes SQL, data manipulation language. I'm not particularly specific about that. People can use really whatever they need. A lot of people are familiar with Python. Some people use R. That is perfectly fine, and it's not, as far as I'm concerned, it's not terribly relevant which language you know and use, as long as you apply it correctly. Basic statistical techniques, we just talked about it. So that includes experimental design. So experimental design includes A/B tests, but it's not necessarily limited to A/B tests. But that is like one big category of experiments. Analysis, which statistical test to use. What's the power of the experiment? What does it mean to have a p-value of 0.05? What are some of the caveats of relying on on hypothesis testing with a p-value of 0.005? That also includes basic data analysis, such as multivariate analysis, including regression and some other techniques. And as we said, also familiar with data pipelines and data warehouses, abstractions, because you will be called to build tables and to build metrics, and in many cases to build dashboards. And in order to do that correctly, and in order to build that also like in a reliable and solid fashion, it's very important that you are familiar with those basic concepts. You're familiar with like basic engineering concepts such as code review, rev control, etc. So that's under technical skills. Then there's like the whole analytical skill / problem solving. That's very important. It's really, are you able to think in a structured fashion and rigorously? Do you have attention to details? So that's like really key to like actually solving problems for the business. Having product and business sense is extremely important, because without it, you may not be solving the right problem, or you may not make the right assumptions, and that might basically you might be ended up in a rabbit hole of analysis that doesn't make any sense from a product perspective, or doesn't make any sense for the business stakeholder that is trying to get that understanding of the problem. So that's really key. And finally, soft skills, we talked about it, but strong cross-functional and communication skills, because if you're not able to work across teams, you will not be able to get your job done. A data analyst often works in a cross-functional team. Usually there might be an operations manager or product manager leading the team, but the team might involve engineering, design, and data is one of them. And in order for data to produce like the right analysis and the right insights, They will need to be able to like work across teams. In some cases, if data is missing, they will need to understand who can help build that data. In some cases, like another team might be um, doing a similar analysis. They should be able to maybe collaborate and consolidate the effort. So cross-functional is extremely important, as well as communication skills, because again, if you do the best analysis in the world, but you can't communicate the result, then that analysis is effectively worthless. The other soft skills is curiosity. Extremely important to have a curious mindset and always asking why and why this and why that, because this is how you get to the bottom of thing. And often organizations will rely on you to equip them with like the deep understanding of what's going on. And that means that if you are the person that the organization rely on to get really that understanding, you really need that curious mindset so that you yourself become the expert and get to the bottom of things. Persistence is important because there will be roadblocks and you will have to overcome them by yourself. Humility, very, very important, because at the end of the day, what matters is that we unearth the truth. It doesn't matter who was right, and it doesn't matter whose idea it was. It only matters that the data analyst is able to summarize what we know of an issue and put their ego aside and really come up with like the best objective vision of like what's happening. And to be objective, you need to be humble, because you need to accept that you might be wrong sometimes, and you need to accept that you might be learning from other people. So it's extremely important to recognize one's limitation in order to produce like objective analysis. And finally, self-drive. This is something that may not seem intuitive at first, but oftentimes a data analyst will work with their business counterpart, and they really need to be able to push things, some of their work stream on their own, because they will get some feedback from their business counterpart or feedback from their manager. But oftentimes they will also have to push their own agenda on their own. They will have to like ask questions of people, seek out answers. And so self-drive is actually extremely important to get things done. So the picture basically that I'm painting here is that I think of a data analyst, or at least a successful data analyst, as an investigator, a data investigator, someone who is given a maybe like a mystery murder, like what caused our depreciation issue, what caused our scooter lifetime to be not as optimal as we think it is, and basically collect all the clues together, use scientific methods to really assign value to different drivers and come up with like a comprehensive answer of what's going on. So really that mindset and mentality of an investigator is really a key driver here. The other thing that I want to mention is that it's often the case that candidates think that the technical skills are the most important, and in reality, they are not. Technical skills really are sort of like table stakes. Yes, it's important to be able to write SQL, because otherwise you can't extract data. But can you learn like more advanced SQL on the job? Yeah, totally. I mean, SQL is like, it's just a language. You need to be able to know the basics, but you can always like, it's easy enough to teach people more advanced SQL if they know the basics. We don't need them to be geniuses in SQL. Same thing with like statistical techniques. It's good to have the basics, and it's important to understand them very well, but we don't really need people who can, tell us like top of mind or by heart all the different moments of different distributions and how they connect together, and the relationship between a Poisson distribution and a gamma distribution. That is really not needed. We just need like a basic understanding. And again, like you can learn, if you need to learn about a Weibull distribution, you can learn that on the job. It is really not required to succeed at the interview level. Same thing with data pipelines and warehouses. I think a basic and good understanding is important. We also don't need people who are like absolute ninjas in that department. What's really important is more like that ability, analytical skills, the ability to solve problems, the ability to use good product and business sense and the ability to have good soft skills, because that is really what makes a difference between an okay data analyst and a rock star data analyst. It's those skills. It's not the technical skills. So putting things together, let's look at how do hiring managers typically assess those skills. So you may or may not be familiar with the process, but I'll run it once more on this slide. So typically starts with a phone screen, and the phone screen is already a place where we can assess communication. Like, are you able to clearly articulate what you've been up to, why you've been doing what you've been doing, how your skills might be lining up to the job posting. So that communication part is very important. It can be assessed even by the recruiter. And so if you're not able to explain what you've been up to in a concise and a precise way, that's already a place here. The second one is structured thinking. If you are being asked questions, you will be also assessed on your ability to provide a structured answer to those questions. So it's very important to have like some basic structure to your answers. Like a typical questions might ask you, tell me of a time when you used data to change someone's mind. Or tell me of a time when you had to solve a problem across teams. Tell me of a time when you were wrong and you had to correct yourself. And even like the answer to that question needs to be structured. Starts by describing the situation, why it was a problem for the business, then how you approached solving the solution, and how the resolution of it basically solved the initial problem. So having that kind of structure is really important to demonstrate. Typically also, the phone screen will be used to assess at some very basic level the technical skills. Does a person know what they're talking about? Can they talk about some of the analysis they did? Whether it's using some fancy statistical techniques, whether it's not. But like we use that also to assess basic technical skills, and always product and business sense, although that is pretty minor at this stage. Then typically it is followed by one or multiple technical screens. And here I include take home when applicable. Technical screens, as the name suggests, obviously are more targeted towards assessing the technical skills. And the reason here is that we don't want to bring candidates on site that don't meet like a minimum bar. And again, this goes back to the comment I made earlier, that really here is the goal is to assess whether candidates meet the minimal bar in terms of being able to extract data, analyze data, do some like basic statistical analysis. And so this will be assessed by a combination of technical screens as well as a take-home. Often the technical screen will also include assessment of problem solving, as well as product and business sense. And of course, we also use that to continue to measure communication, but that again becomes less of the focus on that screen. Finally, the last piece is the on-site. Typically, you can meet like between 4, 6, sometimes more people, and oftentimes people will use case studies to really assess your problem-solving skills as well as your product and business sense and your scientific method. So typical interviews might be around help designing an experiment and analyze it, understand what might be the drawbacks of that experiment. Another typical interview might be around designing metrics for a certain business stakeholder. Why do we choose those metrics? And so that really measure product and business sense, because product is how people use the product. Business is like, why should we care about it? How does that relate to the ultimate business outcome? Analytical skills, often there will be one or multiple interviews or testing whether you can solve a problem. And so having like structured and rigorous thinking is going to be extremely important to solve these problems. And finally, soft skills will also be measured throughout, whether you're curious, whether you're like self-driven, whether you ask questions, and you're able to establish a rapport with the interviewer, also all assessed during the on-site interview. What I would say is that in general, it might be a good idea to practice some of those like case studies with friends or peers who have given them before. If you have friends, for example, who are consultants or have been doing consulting interviews, usually they've done a lot of those case studies, and that might give you a sense of like how to approach those kind of interviews if you've never done them before. So basically, that's the end of what I wanted to cover. I'm leaving like a good 20 minutes for questions. So hopefully now you can have a chance to ask questions and we can answer them.
Awesome presentation. Feel free to stop sharing your slides so our viewers can get a good look at you. But yeah, that was a fantastic job dissecting the difference between common roles in data science today, as well as sort of a really good glimpse into what data analytics teams do. I personally think that was probably like one of the best, like hands down definition of what a data analyst is. It's important, I think, to get such a detailed look into that day to day and why and how this role folds up into a team, especially since sometimes the field of data science can be very hyped and there's a lot of ambiguity around what data science is, but at the same time a very low understanding of what people do day to day. So as a data analyst myself, I actually get this question a lot. And I feel like now I can just redirect them to you. So with that being said, let's move into Q&A. Our first question is from Zachary Thomas. For somebody interested in business analytics that is coming from the accounting/finance side, what methods would you suggest somebody to learn to become adept at like being a good business analytics practitioner? This is more about like basic for data analytics rather than intense machine learning stuff.
Yeah, totally. That's a great question because in fact, I suspect a lot of people are asking themselves the same question: how do I break into the field? What do I need to learn and to do in order to get there? I would say that a couple of things. One is I think what differentiates either business analyst or data analyst from other type of analyst is their ability to like dig really deep into some questions, and in some cases like go do some like forensic on the data. So it's not just taking the data that you're given and like try to play with it and answer questions, but like ask more questions like can I get more data? Where's that data coming from? If I don't have the data that I need to answer the question, can I work with maybe engineers to get that data? What would it take for us to have the correct data instrumented so that I can like do more and more analysis? So that whole stream of like going deeper into like data production and understanding how data is produced, how can we get more and better of it, is a key skill. That it's a combination of like talking to engineers, understanding how to extract data. Obviously, the ability to extract data with SQL from a data warehouse is also pretty key, because without it, you can't really move like upstream in the data production. So that's like one piece. I would say the second piece is also around scientific methods. What are the methods that people use to do like more advanced analysis of the data? So, like regression analysis is one of them. Doing some sort of like statistical test on whether two populations are actually different. Let's say you look at a conversion rate and you have two variants A and B. How can you say that A is actually different from B? The question is that sure, like A might be 1.2% and B might be 1.3%, but are you sure that they are like meaningfully different? So asking that question and understanding which scientific methods we can use to answer that question is also very important. So that's around like statistical tests. And I would say that the third part of it is getting that experience. Like nothing really beat getting like real world experience in solving those issues. So that means potentially volunteering for those projects where you'd be exposed to that like data pipeline or that like statistical test. It's finding any way you can really gain that experience, because at the end of the day, that's really what hiring manager will be judging you on, is that are you able to solve that problem? And the best way to know it is if you've done it before.
Great answer there. And a follow-up question to that is, you mentioned having sort of a good understanding, or at least some understanding of statistical methods, as well as what's sort of important or meaningful between two differences. Are there particular statistics, principles, or principles or concepts that you think come up very often in your job?
Yeah, I mean, basically, it really boils down to causal inference is a very big a field of questions and methods. So being able to drive the right inference about what really happened, or what caused something to happen. So that includes experimental design. But that includes also um, some statistical techniques, such as like regression. In some cases, we might do like more fancy regressions. So that's like one part of it. There's also hypothesis testing, as we discussed earlier. So being able to understand what it means to test hypotheses, what statistical tests we use for different type of situations. This is like a second one. And obviously, I mentioned regression analysis, but that can be thought of as part of causal inference, is that you have a phenomenon that can be affected by a lot of variables. How do you know which variable are really affecting your phenomenon? And how do you know what's the relative importance of those variables? So let's say you want to know what's causing maybe short lifetime of scooters. There are many different causes, and they may vary by regions. And so for each individual scooter, it might be a different reason. But the question is, like, globally, what are the main drivers, and how sensitive we are to those main drivers? And so this falls into the multivariate analysis. And so that's like a general also like series of methods of like how do identify like those different variables and the relative importance between them.
Awesome. Our next question is from Purva Huigol. Thanks again, Purva, for being here and asking great questions the past few days. As newbies to this field, it is often intimidating to apply to bigger data science companies. Should we restrict ourselves in this regard and say start applying to startups for internship positions, or more junior data scientist roles, or you think just go for it and apply to the bigger companies as well? And also, a bit of context for this question is, I think, coming from an idea that sometimes it might be better experience to work in a larger company with like a big analytics division. Or sometimes it might also be better to work in more of a startup situation where you're helping to define the problem and the role within the team.
Yeah, I would say it might sound counterintuitive, but if you don't have a lot of experience, it's actually better to go to a big company, because big companies will have a lot of senior people and people more established in their career, who are able to coach and mentor young or developing data analysts or data scientists. Whereas if you join a startup with like a team of 4 or 5, they actually don't have time to train completely new hires, or like not new hires, but completely new data scientists. And oftentimes they actually can't afford bringing like very junior people. So that's why it's kind of intuitive, but it's for like early in your career, I actually think that it's better to join a larger company, because you will get the mentorship, you will get like the best practices, the structure, and you also be given like maybe a more scoped out and a more narrow question that is easier to answer. The smaller the team you join, the wider the scope and the more open-ended the question, the less mentorship, the less structure, and the more you have to do all of that yourself. So those roles tend to be better for people who are already like mid-career as data analysts or data scientists. So that's like number one. Number two, I would say that really nothing beat getting experience. So if you can't get a job at a big company or at a startup, try to get an internship. Try to get a job maybe at at a company that may not require like the full stack data scientist or data analyst job, but like actually start building that experience. That is like one of the most important thing you can do.
Fantastic. Our next question is from Amit Pudel. Amit asks, based on your explanation or just the sense that I got from the slides, it sounds like people with different educational backgrounds and work experience would be the best fit for either a data analytics or a data science job. Can you please elaborate a little more on this if that was the point you were trying to bring?
I do think that different backgrounds so like fit better to the different jobs. And so, for example, having a stronger background in computer science, having a stronger background in modeling or research, I think fits better with data science. Whereas, typically I think of people with a economics background or like a business background or engineering might fit better with data analytics. But I think, but this does not. It's sort of like this is like secondary. Like the primary differentiation in my mind is people's interest. Are you interested in influencing business decisions on a day to day? Are you and talking to a product manager or an operations manager on a day to day, or are you more interested in taking one single project and like spend maybe 2 weeks researching it and doing like like using like advanced techniques and researching maybe how other people have solved that problem and then coming back to your manager. So if it's the former, then you're probably more data analyst. If it's the latter, then you're probably more inclined to be a data scientist, sometimes called research scientist.
Awesome. Our next question comes from Lewis. Lewis asks, do you think that intuition plays an important role as within having like a sort of data scientist and analyst mindset? And if so, why?
Yeah, I mean, this is what I covered by product and business sense. It is totally intuition. It's like using what you know of the product and what you know about how a business or this particular business works to more efficiently generate the right hypothesis. I mean, in theory, you could like, generate all possible hypotheses, or you could like run a survey across the entire company and get a list of hypotheses and test them one by one. But that's extremely inefficient. And in order for you to be more efficient and like get to the answer faster, you actually have to rely on your product and business intuition.
Fantastic. And next question is actually from Srida. Srida asks, how does one overcome age bias in data science recruiting? By age bias, it may be like a generational gap. Yeah, perhaps more of a tougher question, but I think very interesting.
Yeah. I can see that. I can see that happening at the entry level. That like some hiring managers might have like an image or representation that the entry level data analyst, data scientist looks like a fresh college grad or fresh grad from like a graduate program. And so it might be hard for them to envision that it could also be someone who's had a career before. So I can see that being an issue in those cases. Less an issue on the more senior roles where I think like the experience speaks for itself. So I guess there are two sides of it. One is hiring managers and the recruiting team should internally emphasize fighting against biases, including age bias. And on the candidate side, I would say like how would you do it? Like I think presenting yourself clearly as like either like a newbie to the field and explain why you're a newbie to the field at your stage, or establishing some experience and seniority so that you can come back with that seniority where I think there's less of a mental representation of what it looks like to be a senior data scientist or a manager data scientist.
Yeah, I would totally agree with that. So, our very last question for your session and of the day is from Lucky T. Lucky asks, what is your take on data science boot camps?
Yeah, that's a good question. Okay, so I'll go back to a point I made earlier that at the end of the day, nothing beats experience. So if the bootcamp consists in learning all the different machine learning techniques, SVM, random forest, boosted trees, and how to tune the hyperparameters, that is pretty useless for me as a hiring manager. What I'm looking for more is people's ability to solve real world problem, and frankly that involves often that involves like just wrangling with data, like not finding the data, talking to a lot of people to get it, then realizing that there's a lot of problems with it, having to clean it. Um, and in order to get that, so like those mechanics, I really think like nothing beats having some experience. So I would say like boot camps can be good to get the basic things in place. For some people, it's also like just like a self confidence. Just going through once more like some statistics, it helps them get the confidence that they can actually apply those techniques. But to me, the next step should be to try to get maybe an internship and apply this knowledge and then try to solve the actual problem, because that's where you will get like the right skills.
Thank you so much, Ruben. And I believe with that, that's all the time we have for this session. But thank you so much for volunteering your time and giving such valuable advice. I just personally really resonate with the advice you gave. So it's really awesome. And I'm glad our viewers got to hear that from you. And thanks to all of you for tuning in. This is the last session for CareerCon, but don't leave just yet. We will come back very shortly to officially close out CareerCon. Thank you.